Thank you so much. Well, as I came in, we were right in the middle of standards. So this is going to be a more basic presentation. What what the idea behind this presentation is to explain what is the difference between open source and open standards and how this can save you from vendor lock-in. So let's just jump right into it because I have a lot of slides. So very quickly about me, my name is Peter. I'm from Budapest, Hungary. I'm mainly living in Spain nowadays. I've been working in open source for the last 15 years, worked at Percona and Cloudera, and currently I'm co-founder of FerretDB, which is an open source MongoDB alternative. And I will touch some of that with the content, but if you're not into databases, don't worry. I'm not going to talk much about databases. Agenda, we're going to go through a quick intro, quick recap on open source. It's an extreme task to introduce open source in an open source conference. I think we all know what open source is, but I will still, for the comparison's sake, go through what open source is, then open standards, and then we are going to look at a case study on how each can avoid you getting into vendor lock-in. So why does open matter? We are all here because we like open, we like innovation, we like that open source is cost effective, we like that we can change the course of open source, it's transparent, it's secure, it's collaborative, and this is true both in the case of open source and open standards. So open is the common thing between open source and open standards. And both enables you to avoid vendor lock-in. Let's look at the main differences here. So open standards are the blueprint. Open standards is not an implementation by itself. There is a lot of misunderstanding on the border between implementation and standard, and in reality, open standards should not implement anything. There can be a reference implementation, and that can be open source software, but it's strictly not part of the open standard. And open source is the implementation itself. So if there's an open standard which explains how to interface with a certain software or certain hardware, then you can implement it either as open source software or as proprietary software as well. So let's look at open source. Again, not going to waste a lot of time with that. Raise your hand if you are not sure what open source is. Yeah, so open source is software which has source code available for anyone to inspect, modify, or enhance. We say open source is software with an OSI approved license. This is sadly contested in the industry. It's characterized by community-driven development, and actually it was the default way of writing software in the 50s. So when researchers and scientists were the ones writing software, it was the default way of releasing software. Everybody could just modify it and copy it and use it. And only in the 70s, when the industry, the software development industry, became more mature, proprietary appeared because companies wanted to monetize. So in the 70s, the first OSS projects were born. The good thing about open source, it eliminates waste, waste of duplicate code, so everybody can use them as building blocks, and it's just probably the most efficient way of developing software. It also eliminates vendor lock-in. We're going to look at how, and it's definitely not a business model itself. So the business model is a complete different thing and not part of open source itself. So how does open source eliminate vendor lock-in? Anybody can distribute an open source software, so you don't have to wait for one vendor to get your software from. It is available to anyone. There's no discrimination. There's no one to tell you that you in particular are not allowed to use the software. There are a lot of maintainers, a lot of experts around open source projects optimally, and that provides you the confidence that if something happens, then you will have someone to go to. And the last but not least, it also promotes interoperability. So open source software is very easy to interface with because you know how it works, you know what to expect. It's an open book. However, and this is one of the reasons why I'm holding this presentation today, all of this is not guaranteed to avoid vendor lock-in. So if the open source software is not based on an open standard, let's take an example. Well, I did not come with an example. That's probably not great, but let's say a video player software, which depends on a proprietary codec to play videos. If the author of that codec decides that you're no longer allowed to distribute that codec with your video player software, then you are in a vendor lock-in situation because you may not have any other vendor to get it from. So open source by itself is not enough to eliminate vendor lock-in. I'm also not going to go into the license war here. So what provides you these freedoms are the licenses which comes with the software. There are many types of different licenses. Each are different in a sense when it comes to your rights to distribute the software, for example, or how you're able to use it or what for. But one thing is common between all of the software licenses is that they all follow the definition of open, or the open source definition, which is maintained by the open source initiative. I think the first version is written by Bruce Perens, who was here yesterday. And that states that you have no right to discriminate against use cases, discriminate against specific users. You can't say that no one in Japan can use my software because at that point your license is no longer an open source license. And then the OSI is there to make that decision for you whether your terms would fit into the open source definition or not. The sad part is that even if you call your software open source, that doesn't mean that it is open source. Anybody can call anything open source. There's no trademark. There's no restriction, meaning that if you decide to release a proprietary software and you call it open source, you can actually confuse your users and make them use your software even though it's not providing you the freedoms of what the open source definition would provide you. I will take an example today. And of course, we all know open source software and hardware. You can see the ones with the big X. So when it comes to Elastic and MongoDB, those are the examples I brought for today. MongoDB adopted the SSPL license. They are still calling themselves an open source product. But in reality, the SSPL is not an OSI-approved license. It is not providing you the freedoms you would expect from open source. So there are sad examples on how this terminology is abused. And just for the sake of the eventual comparison between open standards and open source, so how open source project works is that you can start Git repository and write code and push code into that repository, and you can take contributions. It's really up to you whether you accept them or not. It's completely your domain as the maintainer of the code. And if the contributors or the users are not happy with what you're doing as the maintainer or owner of the open source project, then they can just take the source code to a different repository or fork it, as the official terminology, and they become the maintainers of the new code base. So this is entirely dependent on the original authors of the code, whether they allow you to interact with it or whether your suggestions will make it to the repository or the code base or not. Okay, so now that we discussed open source, let's look at the blueprint, the open standards. So the definition of open standards also comes with Bruce Perens. So he's very much all over open standards and open source, because it's actually not that different from the open source definition, in a sense that we are not talking about freedom to distribute, but about availability here. But it's pretty much the same thing, but the purpose or the mechanism is different. So in case of open source, we're talking about distributing software. In the case of open standards, we're talking about who can read and use the standard itself. So you have a standard document and you list the capabilities of the protocol in question or interface, and you provide the blueprint on how to make your software or hardware compatible with that. And anyone should be able to access. There should be no restriction when it comes to the use case or the country or the nationality or whatever else. No royalties, so open standards are free. Sometimes you have to pay for the document, but in theory, these are to cover the expenses of the work on the standard and the distribution of the document, but by itself, there should be no license fee coming with the open standard. Also, an open standard can be extended with proprietary implementation. That means that if you follow a standard, but you want additional features on top of it, then you can do that. You should be allowed to do that. So there's no obligation that you stick to the standard and don't do anything else. Examples of open standards. So in my conversations with many in the industry, there were misunderstandings on what open source software is and what open standards are. As you can see, I think at least some, if not all of these standards should be very familiar to you. We have the PDF standard, or we have CPU architecture. We have the HTTP protocol, which is also an open standard, which enables you to write a browser which can interface with the World Wide Web, can use the same protocol, can use the same interfaces with other software and hardware on the internet, HTML, TCP per IP. Without these, the world would be a very difficult place to navigate. So let's look at one example, the PDF standard. So PDF is a portable document format. Adobe came up with it in the early 2000s. And nowadays, if you book a flight ticket with an airline and you download your boarding pass, you will most likely get a PDF document, and you don't even think twice. You can print it with your browser or just save it on your phone and view it without having anything to do with Adobe, the company itself. Back when it was not an open standard, you needed Adobe Reader or a licensed product to read Adobe PDF, which meant that it was not really popular. It was not popular at all. In fact, its popularity was going down until 2008, when it became a standard. It became an open standard. Other vendors could implement a PDF viewer and that's when this standard became a lot more popular and a lot more accepted as the vehicle of delivering documents to you. The market, after PDF became a standard, the market itself for PDF readers and all kinds of different tools and frameworks around it expanded, and Adobe, the company itself, was probably better off instead of having a semi-dead file extension as opposed to something which became as popular as we know. So that means that there's no fear of vendor lock-in. Adobe is not able to tell anyone that, hey, from tomorrow, the license fee of using the PDF standard is going to be double. They can't do that because they are protected by the standard organizations, as opposed to open source, where you can, as a maintainer, just decide whose input you're going to accept. With open standards, this is very different. There are standards organizations housing standardization bodies, and these standardization bodies are they consist of industry experts, so those who are the closest to the technology itself needing standardization. They have equal votes, so the original author is not able to dominate the discussion and say, no, the standard is going to look like how our business would want it to look like. And also, these standards, as soon as one standardization body accepts it as a standard and releases it as a standard, other standardization bodies can accept it as well. So, so it spreads around the world, and it can become a global standard. Another open standard example, which is probably even better than PDF, the comma-separated values. So imagine that you have software which is able to save contacts. What comma-separated values as a standard provides is that competitors are able to get users migrated from one vendor to another. And you would think, hey, this is bad for the original vendor. But in reality, this expands the market because all of the different vendors can compete against each other, and these enable market players to innovate and to foster competition between each other, expanding the market because the trust of users will also be higher. You are going to be much more inclined to adopt a software knowing that you can export all of the 70, 100,000 contact to a different software. So all in all, how do open standards prevent vendor lock-in? They establish common guidelines or protocols. They enable solutions to interface with each other, and they enable anyone to innovate and challenge the status quo, like in the Adobe case, where you can use any kind of PDF reader to view a PDF. And I brought a case study for you, which goes all the way back to the 70s. And again, I promise you, if you're not into databases, you're still going to hopefully enjoy, because this shows how open source and open standards can work together and what happens if they don't. So raise your hand if you know what a relational database is. SQL, the query language. Okay, so most of you are familiar. So relational database is pretty much most databases around the world. You use a relational database or a relational model, and how you interface with a database, how you get data in and out of it is through the through the query language called SQL. And this is just something we take for granted. If you want to interface with a database, then you just use SQL no matter what the product is, what the name of the product is. So how this started is that there was an IBM Research Center in the 70s. There was a person called Edgar Codd. He was a researcher in the Palo Alto IBM research lab, and he came up with the relational model. Before that, it was much less efficient to store data in a database and to query data from a database. He came up with a relational model, and that enabled, theoretically, it enabled users to store more data and work with more data. However, the query language he came up with included mathematical formulas, so it was very much complicated to query a relational database based on Edgar Codd's idea. So there was Don Chamberlain and Ray Boyce who came up with SQL, which is an English-like plain language way of querying a database. Of course, this is the 70s, so plain language is not like the AI of today, but still it was much more easier than writing a mathematical formula to query a database. So they laid out the foundations of the SQL query language, and this was so successful that IBM was able to pave the way for computer databases in general by releasing a product which implements the relational model and also SQL as a query language you can use with it. However, you had to buy this washing machine or several washing machine sized computer. You had to buy the license from IBM. So if you liked SQL, if you liked the easy way to query a database, you had to go to IBM and pay whatever price they named. And then others liked what IBM was doing, but it was proprietary. So they started implementing competing products which kind of worked in a similar way. But in reality, if you used IBM DB2 and you wanted to get away from it and use Informix or Sybase or another competitor, you couldn't use the same query language. It was basically impossible for you to use the same knowledge you gathered while working with IBM DB2. So there were many different dialects, no conformity between products, very different feature set. It was not possible to migrate, which is the definition of vendor lock-in. This was the 80s. And then SQL became an open standard, and it was deemed so important that an open standard was created. It became an ANSI and ISO standard, and from that moment on, anybody could implement SQL the same way and release products based on that. However, all vendors were still proprietary, means that you are still in a vendor lock-in situation. So migration was still not as straightforward as with open source software, because the specifications of each alternative was not known. It was not an open book like open source software is. So all vendors were proprietary, and it was only in the mid-90s and early 2000 that open source projects started implementing SQL. Postgres, which is one of the most well-known relational databases out there, did not support SQL from the 60s to the late 90s. And then they implemented it based on the open standard, and that's when SQL became available to anyone. And that was the motion which enabled all of us to just leverage SQL like we do today. And since then, hundreds of derivatives appeared, and what is most common between them is at least a baseline standardized query language. And So this is hopefully something you were familiar with, and it underlines the importance of open standards when it comes to making a specific technology popular. So what if there's open source software but without a standard? I mentioned MongoDB before. I'm not impartial to this topic because FerretDB is actually a MongoDB alternative, but I promise that this is the best I can do to be impartial. So MongoDB is one of those companies where they started off very similarly as IBM DB2. The promise was that you don't need to be a database administrator, like with scary relational databases, to run a database, that it's going to be so easy for you to query data that it's just much more easy to use. Very similar to SQL in the 70s. It promised an easier way to interface with a database. And it was really successful. It was an open source software. Adoption was steadily growing. However, in 2018, they adopted a license which stripped the user from some of the freedoms which the open source definition provided. Meaning that they called something open source which was no longer open source. And there was no alternative because they were so successful. Everybody thought, hey, there's no vendor lock-in because it's open source. And then in 2018, everybody found themselves using a software which is no longer open source and without alternative. And this is a very familiar slide, but with different products. So as soon as that happened, others started implementing similar products to MongoDB, claiming that they have a degree of compatibility. But since there was no open standard, there was nothing they could develop their products against, which means that these are not compatible with each other. These are great products, the same way as with relational databases in the 80s, but you cannot migrate between them. So without an open standard, open source was not able to save you from vendor lock-in due to the exact same thing as what happened in the 70s. They all have a vastly different feature set. They have a different degree of compatibility. As a software developer, if you run a query, you don't know whether that is going to run or not because that feature may be missing from the alternative. So the point of this presentation was to show that open standards such as SQL and such as a standard which is coming at us for document databases, at least this is what we are working on. Open source and open standards together is the combination which can actually save you from vendor lock-in. So whenever you're looking at a software you would like to adopt, I just wanted to underline that it's not enough to have just an open standard, just open source. Optimally, it should have both, as we have seen in the case study. And if we have that increases competition. It's good for you as a user, and it fosters innovation. That was it. Thank you so much for your attention. I'm not sure if you have questions.